Today, we're going to watch a complete takeover of a cloud environment. We're going to follow an ethical hacker step by step as they turn just one single leaked key into total administrative control over an entire AWS account. So let's dive in and see how it's done. I know, it sounds like something straight out of a movie, right? But the crazy thing is, it's totally possible. As we're about to see, just a couple of small misconfigurations are all it takes to pave a direct path for an attacker to get complete control. And we're going to follow that exact path, command by command. So, before you can break into any system, you've got to understand its security. And in the world of AWS, that means you have to understand IAM, Identity and Access Management. Think of it as the digital bouncer for absolutely everything in the cloud. Let's think of it like this. Imagine IAM is the security system for a huge corporate skyscraper. It's the system that issues every single keycard, and it decides exactly which doors each of those keycards can open. It's all about controlling who has access and what they can do once they're inside. Okay, this next part is super important to get, the difference between users and roles. A user, that's a permanent identity, kind of like an employee's ID badge. It just says who you are. A role, on the other hand, is a temporary set of permissions, more like a special access pass you get for a specific job. It defines what you can do. And trust me, this distinction, it's the key to this entire attack. So, if users and roles are the key cards, what are the rules? Well, that's where policies come in. A policy is basically a document, a rule book, that's attached to the key card. It explicitly lists out what actions are allowed or what actions are denied. For example, a policy might say, this person can read files here, but they definitely can't delete them. Every single identity in AWS has policies attached. All right, theory's over. Let's get to the good part. The attack is beginning. Our red teamer, our ethical hacker, has gotten their hands on a set of credentials. They have their first key, and they're about to walk right through that front door. So how does this whole thing kick off? Well, it all starts with a leaked access key. It's got two parts, an access key ID, which is like a username, and a secret access key, which is pretty much the password. These aren't for logging into a website. They're for programmatic access, letting tools and scripts talk directly to the AWS environment. So what's the first move? The attacker takes those stolen credentials and loads them up into their toolkit, the AWS Command Line Interface, or CLI. This command, AWS Configure, is basically them saving that keycard info under a profile name. Here, they're calling it Auditor, so they can easily use it for every command that comes next. Okay, the key is loaded. But does it even work? You gotta check, right? This next command is like swiping the keycard at the security desk just to see whose name pops up on the screen. Get caller identity confirms exactly who you are according to those keys. If it returns user account, bingo, the red teamer knows they're in. So our hacker's in, but right now they're basically standing in a pitch black room. The next step is to flip on the lights and start mapping out the place. This is the reconnaissance phase, all about finding a path to more power. You're inside. What's the very first question you ask? Am I alone? You want to know what other users exist in this account. Are there any big fish? You know, any administrator accounts? That would be the ultimate prize. And to find out, they run a really simple command. AWS IAM list users. This is just like pulling up the entire company employee directory. It spits out a list of every other user in the account, which is basically a list of potential targets. After checking for users, the next hunt is for something even juicier, those special access keycards we talked about, the IAM roles. These are often way more valuable than user accounts because they're usually attached to automated systems and servers, which make for some prime targets. And just like that, with AWS IAM list roles, they get a full list of every single role in the account. Now, they'll scan this list for interesting names, things like admin role, or in our case, roles that are attached to servers, which are called EC2 instances. This is where they really start looking for that one weak link in the chain. And that's when they find it, the weak link. This right here is the turning point of the whole attack. It's called privilege escalation. This is the moment the hacker finds a tiny crack in the wall and pries it open into a giant door, taking their access from some low-level user to something way, way more powerful. This isn't just random hacking. There's a playbook, a life cycle to this kind of attack. We've already seen step 1, the initial access, and step 2, the enumeration. Now we're at the fun part, step 3, exploiting a service to grab a new, more powerful set of credentials. And here is the pivot, the big move. Our hacker found a public server that had a vulnerability. This flaw lets them trick the server into making web requests for them. So they tell the server to visit this special, internal-only web address. That address is actually the server's own metadata service. And guess what it holds? The server's temporary IAM role credentials. The vulnerable app just hands them right over. Just like that, they've stolen the server's identity. Okay, this is it. The moment we've been building towards. Armed with these new, powerful credentials they just stole from that server, our red teamer is ready to make their final move and seize complete control of the entire cloud. And it all comes down to this one single critical flaw. The role our hacker just compromised has a ridiculously dangerous permission. It's allowed to modify its own permissions. That's like having a key card that can program itself to open any door in the building, including the one to the main security office. And here it is, the final blow, the kill shot. With one single command, they use the role's own power against itself. They tell AWS, hey, see that administrator access policy? The one that grants full control over everything? Yeah, go ahead and attach that to the role I'm using right now. And because of that fatal flaw, AWS just says, okay, you got it. And just like that, it's game over. The hacker who started with one lonely, low-privilege access key is now a full administrator. They own the entire environment. They can read all the data, delete every resource, and lock everybody else out. Mission accomplished. So let's just quickly retrace those steps. It all kicked off with one leaks key. That key let the hacker look around and find a misconfigured role on a server. And that role had one fatal permission, the ability to change itself. That single flaw was all it took to jump from a nobody to a full administrator, a tiny little crack that brought down the entire wall. So we've just walked through the attacker's entire playbook, from a single key to total control. It's a pretty powerful thing to see, but it leaves us with the most important question of all. Now that you know exactly how they get in, how would you stop them?